In this video, we solve a Laplace transform problem where the transform is given and we determine how many possible time domain signals can produce it. In this question, a Laplace transform is given and we are asked to determine how many signals can have this Laplace transform. To do this, we first need to find the number of possible regions of convergence for this Laplace transform. Then, based on the number of ROC, we can determine how many different signals can have this Laplace transform. To solve this problem, we first need to review a few points. The first point is what we mean by a rational Laplace transform. A rational Laplace transform is a Laplace transform whose numerator is a polynomial and whose denominator is also a polynomial. A fraction like the one given here is called the rational Laplace transform. The second point is that for rational Laplace transforms, the ROC cannot include any poles. This is because we know that a pole makes the Laplace transform go to infinity, while the region of convergence or ROC is the region where the Laplace transform converges and is finite. Therefore, these two are in contradictions and the pole cannot lie inside the ROC. Another important point is that the region of convergence is either bounded by poles or it extends to infinity. Now, let's solve the question. First, we need to determine the zeros and the poles. Zeros are the values of S that make the Laplace transform equal to 0. In rational Laplace transforms, these are the roots of the numerator. In this case, S equal to 1 is a 0. Poles are the values of S that make the Laplace transform go to infinity. In rational Laplace transforms, these are the roots of the denominator. Here, the roots of the denominator are S equal to minus 2 and S equal to minus 3. We also have a second order equation, and using the quadratic formula, we can find its roots. If we substitute the coefficients, we obtain the roots as minus 1/2 plus and minus j, the square roots of 3 divided by 2. We should also remember that when the roots are complex, they must appear as complex conjugate pairs. That means we cannot have only minus 1/2 plus j times the square root of 3 divided by 2. We must also have minus 1/2 minus j times the square roots of 3 divided by 2. Now, let's draw the pole zero plots. In a pole zero diagram, zeros are shown with circles and poles are shown with crosses. If we mark the poles and zeros here, the diagram will look like the figure shown. Now, based on the first and second points, the first possible ROC consists of all S values whose real part is greater than minus 1/2. If you pay attention, there is no pole in this region. This region starts from the pole at minus 1/2 and extends to infinity. The second ROC consists of S-values whose real part lies between -2 and -1. Again, there is no pole in this region, and this region is bounded by two poles. The third region of convergence consists of S-values whose real part lies between -2 and -3. Finally, the fourth ROC consists of S-values whose real part is less than -3. Now, since we have obtained four different ROC, we can conclude that there are four different signals, which we can call x1 of t, x2 of t, x3 of t, and x4 of t, that can have this Laplace transform. This was a sample problem from the topic of Laplace transforms. If this video was useful for you, you can follow our other videos on this channel as well.